Almost you all have drank water from hand pump, didn't you? Yes you did, or at least you have seen. Then, what do you think? How it extracts water from deep down ground? Or have you given any thought that how tall buildings receive water from ground to top floor? Example Burj Khalifa, Empire State Building, so on. We use a mechanical device called pump. Before that, let us understand what is pump. Pump is mechanical device which converts mechanical energy into hydraulic energy. Now let us understand what exactly is radial piston pump. A radial piston pump is a type of hydraulic piston pump and the working pistons expand within a radial track symmetrically in the region of the drive shaft. Let us see what are the construction made for radial piston or components of radial piston pump. As shown in the below figure, the piston pump consists of different parts. The major components of a radial piston pump are: number 1 is pintle. A pintle is a round bar that serves as a stationary shaft around which a cylinder block turns. As you can see the simple compound diagram of pintle. If you want to learn in detail about pintle, then type lecture on pintle on the comment section. Another component is cylindrical block. A cylinder block is a block of metal with a hole bored through its center to fit the pintles and cylinders holes that are bored equal distances apart around its outside edge. Given diagram is a simple compound diagram of cylindrical block. Another major component is piston. A piston goes back and forth in a cylinder while it rotates about its axis so that the top surface will wear uniformly. Shown figure is a simple diagram of piston. Now this inlet port is channel through which fluid enters inside the side block. Spring is used to retract the piston position. Now the minor accessories are: check valve, drive shaft, inlet and outlet port at pintle, center line cylinder block, rotor, seals, housing or casing. Now let's see in detail working of radial piston pump. In a radial piston pump as shown in figure, the pistons are arranged like wheel spokes in a short cylindrical block. A drive shaft, which is inside a circular housing, rotates a cylinder block. Let me put this working in a point-wise so that you may be able to understand it easily. In a radial piston pump as shown in figure, the pistons are arranged like wheel spokes in a short cylindrical block. A drive shaft, which is inside a circular housing, rotates a cylinder block. The block turns on a stationary pintle that contains the inlet and outlet ports. As a cylinder block turns, centrifugal force slings the pistons, which follow a circular housing. A housing's centerline is offset from a cylinder block's centerline. The amount of eccentricity between the two determines a piston stroke and, therefore, a pump's displacement. Controls can be applied to change a housing's location and thereby vary a pump's delivery from 0 to maximum. When a pump has an uneven number of pistons, no more than one piston is completely blocked by a pintle at one time, which reduces flow pulsations. With an even number of pistons spaced around a cylinder block, two pistons could be blocked by a pintle at the same time. If this happens, 3 pistons would discharge at one time and 4 at another time, and pulsations would occur in the flow. A pintle, a cylinder block, the pistons, a rotor and a drive shaft constitute the main working parts of a pump. Now watch the working video model of radial piston pump. They have many advantages, such as high efficiency, high pressure capability up to 1000 bars or 14,000 psi, low flow and pressure ripple, noise level, very high load at the lowest speed, high reliability. Its disadvantage is the bigger radial dimensions in comparison to the axial piston pump, but it could be compensated with the shorter construction in axial direction. The following may applications for a radial piston pump: machine tools, example displays of cutting emulsion, supply for hydraulic equipment like cylinders, high pressure units, example for overload protection of presses, test rigs, automotive sector, example automatic transmission, hydraulic suspension control in upper class cars. Thank you all. This takes a lot of love to watch this video till end. If you liked my work, then subscribe my YouTube channel with me engineering. And if you love this video and you want me to make more videos on upcoming topics, then write your love in comment box. For interesting facts about engineering and more fun information, then follow me on our Instagram page. Our next video will be on properties of hydraulic fluid. Keep watching.